Welcome everybody. Pause the video and read the question carefully. As we can see, the question is describing the neutralization process that was done between hydrochloric acid and sodium hydroxide. They're mixed together. You just notice that the enthalpy change of a neutralization is always negative since it's an exothermic process. And the resin temperature in the first experiment was 12 degrees Celsius. The question says, in the first experiment, we used 25 and 25 of acid and base together with the same concentration, sodium hydroxide and hydrochloric acid. And this experiment is repeated again, but the difference here that the volumes are doubled. And generally speaking, if you look at these questions like for the first time, you say like, okay, since the delta T, if we have like the first delta T when we use a 25 cubic centimeter for both, just like give us 12 degrees Celsius, if we double the volumes at this point, we're supposed to have it 24 degrees Celsius. But this point is not solved in this method. We have to remember something else or relate our answers to something else. The first part of my solutions, I want to write the equation of a neutralization. It's represented by NaOH plus HCl produces H2O and NaCl, and it's balanced and it's 1-to-1 ratio. The first experiment, I just want to divide it into two sections. The first experiment, we used 25 cubic centimeter of NaOH, and the same thing here with hydrochloric acid. We used 2 mol per decimeter, and the same thing here, we have 2 mol per decimeter. And now we have to write or to calculate the delta H for this. There is equal to negative MC delta T over 1000 times N. And at this point, we have to revise tomorrow's meaning of those. So first of all, the negative here, which is in the same law, and it's multiplied by M. And M here represents the mass of aqueous solution. And since we're dealing with 25 cubic centimeter of acid and 25 cubic centimeter of base, then you have to add them together in order to have 50 centimeter cubic, but actually it's a unit of volume. And that's why we're supposed that the density is equal to 1, and thus their mass is 50 grams at this point. So we have to say 50 times, C here represents the capacity constant, which is 4.18, and then we multiply it by the resin temperature, which is 12, and okay. And we divide it over 1000 in order to change it to kilojoule per mole, and then we have to divide this over mole. But those moles represent what? They represent the number of moles of water because we're dealing with the neutralization. And at this point, since you have the same number of same number of moles of HCl, there is no need to determine the limiting reactant. So the moles of water in the first experiment are equal to 25 over 1000 to change them to moles, and then we multiply them with a concentration. It equals to 0.05 mole of water. At this point, we have to put this 0.05. So if you use your calculator, we will have, then the answer is equal to 50.16. And you have to remember something. Since the experiment here is done with a strong acid and a strong base, okay, then we are dealing with a delta H that it could be constant under the same conditions. By the way, this experiment wasn't done under standard conditions. But if I made another experiment, like with a strong acid and a strong base, regardless the amounts that I'm using, the delta H should be the same. And actually, it's written here. It says that in the second experiment, the same method is used. We use the same method. We're using the same conditions. And at that moment, since we're using with the strong acid and strong base, we're supposed to have a delta H of 50.16 in the experiment number 2. So it says that in the experiment number 2, we changed the volumes to be 50 for acid and 50 for base. And let's repeat it again. The question actually is asking me to calculate the delta T in experiment 2. So we have to say, since the delta H is the same, you're using a strong acid, And if you remember something I said about the enthalpy change of a neutralization of once in its standard between a strong acid and a strong base, it's always negative 57. And this number represents the magnitude of enthalpy change per mole of water, like regardless the amount of acid and base, as long as they are strong. Okay, so this is the idea at this point. Okay, so we have to say minus C delta T over 1000 times N. And you just remember that N here represents the moles of water. But the moles of water here are not the same as the moles of water in here because we have double volumes. How can I do this? And HCl plus NaOH reduces H2O plus NaCl. Since the moles of NaOH and Cl are equal, then they have the same number of moles at this point of water. And the moles of water are equal to 50 over 1000 times the concentration, and actually it equals to 0.1. So we can substitute the 0.1 in our law down below, minus the mass at this point is equal to 50 plus 50, in which we have two volumes of acid and base, and that's why they're 100. We multiply them by the value of the capacity, and delta T is unknown. We divide them over 1000, and this is 0.1, and we have to use this value that was calculated because we're using the same condition. We're using the same strong acid and base. All right, 16, and here you have 50. And if you use your calculator at this point, delta T is equal to 12. And this is actually, the answer here is B.